Okay, so today I wanted to show you the overview of how I'm going to replace the traditional electronic DK bongos with a set of real bongos. Now the goal is to take those and connect them somehow to a Nintendo GameCube. That system breaks down roughly as follows. We have sensors, we have processors, we got Bluetooth, and we got the GameCube. So for sensors, we're going to have two kinds. The first kind is a microphone. Now a microphone is able to have amplitude and pitch, which will allow us to know which part of the bongo is being hit and which bongo is being hit. And then separately, we're going to have an accelerometer. And the accelerometer's job is to disambiguate between multiple sets of bongos. So if someone else is playing bongos near you, for example, if you're all playing Donkey Konga together, the only inputs you want to be valid will be the ones coming from you hitting the bongos. And that's what this sensor will be able to do. It's an accelerometer and a gyroscope, and we're going to take the accelerometer and gyroscope inputs and send them to the processors. In order to make that job a little bit easier, we're going to use a standard Arduino. This one's the Pro Mini from Adafruit, and we're going to collect data from the sensors, repackage it, and send it to the big boy. Oh, I love this guy. This is a Google Coral. Now, if you don't know anything about the Google Coral is a edge TPU, tensor processing unit, used for machine learning inference. So we're able to run models on this and do inference, and that inference will say, hey, we heard this and felt this, therefore this player hit this part of the bongo, and therefore we map it to this button. Finally, that will communicate over Bluetooth low energy to this Espressif ESP32 module. This is a feather board from Adafruit, and that will be connected to the GameCube over a custom GameCube port that'll plug in to this bad boy. Now, that's the system overview. I expect it to take about 6 months to narrow this down and make it work. One of the important things is that basically every single part of this can be replaced with a test harness. So I'm going to be developing each piece individually and wiring them up together through integration tests. That's a standard practice in engineering, to take something complicated and break it down into simpler parts. So basically all of this stuff can be either run or emulated on Shoebox. Now, Shoebox is my big beefy PC, and the way that that will work is we have a GameCube controller adapter. So we'll be able to start with the DK Bongos, connected to the computer, connected to an emulator running Donkey Kong Jungle Beat. And I love this game. We'll be able to replace Shoebox eventually with the Google Coral, but that comes much, much later. Initially, we're going to have we'll have the sensors connected to the Arduino Pro. That will send data to Shoebox. Shoebox will then run inference and send the input to the emulator. Eventually, we will also be able to have Shoebox connect over Bluetooth low energy to the Featherboard, which will then connect to the GameCube. So Shoebox is the real key player for all of the test harnesses, and Shoebox is the big player for all of the test harnesses, and we're going to make each subset work with Shoebox first before trying to wire them up. So those components are roughly the sensor pack, then we have the inference, and then we have the GameCube inputs. So I think that should be enough. I'm planning to do 2 sets of sensor packs, one in each bongo, in order to more differentiate between the two. I think that's overkill. Just like I actually think that this TPU is overkill, this thing is capable of processing video in real time. We're going to be trying to process 16 milliseconds of data in about 5 milliseconds in order to get the throughput that we want, and the latency between the Bluetooth system should be enough that we want roughly 25 milliseconds total between when you hit the bongo and when the hit is registered. The GameCube runs at about 60 frames per second with regards to inputs, so you can do a max of 60 inputs, and that is going to be more than I think we can reliably get out of this system as it's going to stand. Now, all of that is going to be jammed inside of the 2 bongos. The Coral will sit in the big bongo in a 3D printed harness, and the sensors will sit one set here and one set here. There'll be a little wire. And then because the Coral requires 3 amps of power in order to run its edge TPU, we're gonna keep this wired for the foreseeable future. This will not be a wireless setup until we can replace the edge TPU with a much lighter system. Because this runs embedded Linux, it's essentially a Raspberry Pi, and that means that we're going to be running TensorFlow Lite on this chip to do the inference. And then the sensor packs, this will just be a Arduino sketch, and similarly through the ASP32, this will be an Arduino sketch sending data to the GameCube. We have a really interesting problem here where the GameCube provides 50 milliamps of power, and we need 20 for the chip, and we need 30 for the Bluetooth. I would like to get away with only using power from the GameCube. I am willing to provide external power during the development process. And that is how I'm going to play Donkey Kong Jungle Beat with a set of real bongos.